Today's problem is sum of mode, difficulty hard, accuracy 62%, very high. I guess this is a pretty new problem. There's only 2,000 submissions. Usually it's much higher than that. 20 minutes, that is low. This is a hard problem. I mean, the algorithm isn't super hard, but I would say it would be hard to get, every detail of it exactly right in 20 minutes, 62% of the time. But anyway, let's take a look. Given an array of positive integers and an integer k, you have to find the sum of the modes of all the subarrays of size k. Note the mode of a subarray is the element that occurs with the highest frequency. If multiple elements have the same highest frequency, the smallest element smallest such element is considered the mode. Okay, that's important. Let's take a look further here. Constraints k and the size of the array will be somewhere between 1 and 10 to the 5th, 100,000. The elements in the array will also be between 1 and 100,000. Expected complexity n log k. Okay, that is suggestive of something, and we'll come back to that in a second. Topic tags. Set, yes. Greedy, I guess so, yeah. Sliding window, yes. Two-pointer algorithm, sort of. Hash, yes. The definite yeses are set, hash, sliding window. Okay, analog K. Sliding window. So a sliding window suggests that we are just going to take one pass through the array with a sliding window. That would be O of n. So what is the log K? The log K suggests that we may be able to use an ordered data structure, meaning a tree map or a tree set. Those are available in Java. Unlike a regular set or map, a tree set and a tree map keep the entries in sorted order. Okay, but in exchange for that, operations that would normally be O of 1 on a map or set are log operations, because there's more overhead in maintaining the ordering. So n log k it suggests an ordered data structure. And in fact, we are going to use an ordered data structure. But let's take a look at the example here. So all of the sub arrays of size 3, and we can use a sliding window. Okay, so the sliding window would start here, 1, 2, 3. What is the mode? It's a tie, but remember that the tiebreaker is that the smallest element is the mode. So the mode for the first, and they're all listed down here, but the mode for the first window is 1. Here's the second window. The mode there is 2. 2 is the most frequently occurring. This is a tie. We take the smallest, which is 2. 2 is the most frequent here. This is a tie, and we take the smallest, which is 2, and then finally the mode here is 4. Add them all up, it's 13. We're going to use the second example as our working model here. Let me slide this over a little bit so we can see everything. Okay. All right, let's start. N is the length of the array. Sum is initialized to 0. Map. The map is going to be used to store the frequency of elements in the current window. Tree set. That is an ordered set, and we have a custom comparator. In order to get the mode, we're going to use the tree set, and we're always going to take the anytime we want to get the mode, we're going to take the last element in the tree set, And the tree set is going to be, it's going to store two element integer arrays. The first element is going to be frequency. And again, that's going to be stored in increasing order because we want the element that occurs the most. Now, the tiebreaker, if the frequencies are all the same, is we're going to take the lowest value. But as I said, we're sorting it ascending. So it's possible that I mean, here's the comparator. If A0 is not equal to B0, that is that the frequencies are not equal, then what we want is we want the frequencies sorted in ascending order. If the frequencies are equal, we'll sort the values in increasing order. It's possible that this could work, and I haven't tried it, by switching these and saying compare B1, A1, and sort it descending. So sort the frequencies ascending, sort the values descending. It seems a little clunky to me, but we have to do something. So actually what we're going to do is we are going to just negate the numbers when we put them in the tree set. I don't know, can we get an example of this? Yeah, so this window right here, for example, would go in the tree set as follows. We would have, the frequencies are all 1, so we would have 1, and we would have -3. We would have 1, and we would have -2. We would have 1, and we would have -1 and -1. So everything is ascending. We would pull the last element from the tree set, take the -1 and negate it back and say, okay, the mode is 1. So everything is ascending. All right. Next, build the frequency map for the first window. That's what we're doing in this for loop. Let's see. So array at I, and actually I would like to scroll this so I've got some room. All right, array at 0 is 1. So we're going to put in the map 1, and so far it occurs 1 time. This is our window right here, and we also have a 2, and the 2 occurs 1 time. Okay, now we're going to put the map entries into a set. All right, so what we'll add to the set is a 2-element array. One is get value, and the value is this column, the second column. Value is going to be 1, and it's going to sort in this order. Well, actually, yeah, I can put them in like this, but we're going to put them in like this. We're going to put everything in the map into the set. Frequency first, followed by negative value. All right. I think I can do this. Now from here, I think I can scroll it up to the main for loop. Yes? Okay, good. All right, so our mode, the mode for the first window is going to be set.last. Set.last, because it's ordered, is going to be this right here. We're going to take the element at index 1, which is -1, and negate it. So the mode is 1, and sum, which we'll put down here, will be currently 0 plus equal that mode, which is 1. All right, now we're going to go I from K to N. N is what? Less than N. K is 2. Okay, let's keep track of that. Out will be array at 2 minus 2, array at 0. So out is the 1. That is the value that when we slide the window, we are going to slide that number out. So out will be 1, and in will be array at 2, which is also a 1. Okay, at this point it's probably a good idea to indicate that our new window is here. All right, out, frequency. So now we have to update the map because we just lost a 1. So out, frequency equals map, get out. Frequency of 1 is 1. And we're going to remove from the set 1, -1, which is here. Okay, it's out of the set. Okay, if map, I'm sorry, wait. Map, I'm sorry. Map put, what we do is update the map. Set remove. Okay, we removed from the set, but the map put, we have to update the map. Out is 1. Out freq minus 1 is 0. So the map now looks like this. It's possible, although not in this example, that number would not go to 0. In this case, and we could re-add it to the set, with the updated frequency. But in this case, it is 0. So we remove it from the map. Okay, it's gone. Sorry, that's a highlighter. So it is gone. All right, and now we put map in, which is actually the same thing. It's a 1, and it occurs 1 time in the current window. So 1 and 1. Why did we take it out and put it back in? Well, we just didn't know that was going to happen. So let's see. Map put, okay, set, add. So now we have to add it back to the set. And the frequency is going to be 1. And the value is going to be -1. All right, mode. Again, we're going to take the last element, second number, negate it, it's 1, add it to the sum, and the sum becomes 2. All right, we're back up here. K is going to go to 3. Out at 3 minus 2, out at 1. So the number that's going to go out is a 2. The number that's going to come in at index 3 is a 3. The frequency of the number going out 2 is 1. So what we removed from the set is 1, -2. Okay, so that is coming out. I didn't mean to do that. Map put out frequency -1. So the number of 2's, oops, I should update the current window. Current window is now here. And the number of 2's in that window is 0. All right. And because it's 0, we're going to remove it from the map. Oh, gosh, I always hit the highlighter. All right, remove it from the map. Map put, increment the frequency of the incoming element. The incoming element is 3. So 3 goes in here, and it occurs 1 time. Insert the updated frequency pair for the incoming element. Again, it's going to go in this order because frequencies are the same and the numbers go in ascending order. Okay, get the current mode. Current mode is, let's see, set last 1. It's the -1 again. So we negate that. It is 1. The mode of that window is 1. Okay. And back to the top, this will be the last time through the loop. Okay, now it goes to 4. Because we're sliding the window, let me go ahead and do that now. This is going to be our new window. Leaving the window will be index 4 minus 2, which is a 1. 1 is leaving, and coming in is array at 4, which is a 5. The frequency of the 1 going out is 1, so we remove 1, negative 1 from the set. Okay. Map, put, increment the frequency of the, wait. Okay, yeah, decrement the frequency of the outgoing element. And because it is 0, we remove it. Oh, sorry. Map, put, out, frequency, update the, decrement the frequency of the outgoing element, and because it's 0, it is coming out of the map. All right. Frequency is still positive? No, it's not still positive. Increment the frequency of the incoming element, which is a 5. Okay. So we'll have 5. It occurs 1 time. Insert the frequency pair for the incoming element, and that is going to insert up here in an ordered set. 1, negative 5. Okay, good. Get the mode. The mode we can get from the last element, the element at index 1, which is a negative 3. We negate that, and so we have 3, and we add that to the mode. 3 plus 3 is 6. We are done. That's it. All right. So to kind of recap, we take the first window, we add the element and the frequency to our frequency. We take the first window, add the elements and their frequencies to the frequency map. We populate the set, the tree set, with the initial frequency pairs, and based on that we can get the mode of the first window. After that, we drop into this loop here, the for loop. With the for loop, we slide the window, remove the outgoing elements frequency pair from the set. Okay? We update or decrement the frequency of the outgoing element in the map. Now, if the frequency is still positive, we can add the updated frequency pair to the set. If the frequency is not still positive, we just remove it from the map. All right? We increment in the map the frequency of the incoming element, and we insert the updated frequency pair for the incoming element in the set. Having done that, we can get the mode of the current window and add it to the sum, and that's it. We slide the window all the way across. We should probably run this. Okay. So let me get back here. Submit. Okay. Go ahead and like the video. You can subscribe to the channel. It's free, and I'll send you a problem. I'll send you problems of the day every day in your inbox. You're not required to do them, but you'll have them if you want to do them. And that's it. We'll see you next time.